Today, in this session, we will not only look at fatigue life under constant amplitude loading, but also under variable amplitude loading. Apart from that, we will be covering the rainflow cycle counting technique under the cycle counting techniques, and also the general methodology used for life prediction. If there is a block of loadings is applied with the constant amplitude loading, it is possible to find out how many number of times small n is being applied for a given stress amplitude. In this case, the two blocks are given, and based on the number of cycles applied for the given stress amplitude, and for given r is equal to -1, one can refer to the SN curve for r is equal to -1, and accordingly, one can find out the damage based on small n by capital N for the given stress ratio. So generally, it is represented as the summation of damages due to the each stress by knowing small number of cycles that is being applied, and the number of cycle to failure obtained from the SN curve. So as long as this relation holds good, then one can find out the life of a structure. Now, going to the variable amplitude loading, one would expect in this sequence where stress ratio is 0, but they have a different stress level, sigma 1, sigma 2, sigma 3. And one can refer to SN curve for is equal to 0. And one can find out D1, D2, and D3. Then afterwards, one can find the total damage as a summation of D1, D2, D3. Then take the reciprocal of it to get the number of cycles to failure. Now, when it is extended to typical aircraft spectrum, still one can identify and isolate the number of peak and troughs that constitute a cycle and number of times it is forming a cycle. Based on that, one can find out the respective damages. Then later on, total damage can be calculated. Now coming to the cycle counting technique, basically it is associated with cycle ratio n1 by n. That's what we saw from the Miner's rule. And this NF can be obtained from baseline fatigue data generated from constant amplitude loading test. And applying the linear damage rule, for where the knowledge of mean stress and amplitude of stress sustained, which is damaging event, is made available. So for case that exhibit constant amplitude loading with or without mean offset loading, the determination of the amplitude of cycle and the number of cycles experienced by a component is straightforward exercise. But in the case of variable amplitude loading, it is more difficult to determine what constitutes a cycle and the corresponding amplitude of that cycle. So cycle counting technique is the method to determine number of cycles in a spectrum. So there are different techniques available. There are level crossing cycle counting, peak value cycle counting, range counting, and rainflow cycle counting. Since rainflow cycle counting is popular and adopted in aero industry, we'll just briefly give the overview of rainflow cycle counting technique. So, two Japanese researchers developed this rainflow counting method by relating the stress reversal cycle of streams of rainwater falling down a pagoda. Generally, it is regarded as the most accurate cycle counting method. So the cycle with respect to time, be it stress, strain, or displacement, that can be visualized by rotating 90 degrees and to see whether water flows down the line or it gets stops in between. So similar logic is used for 3-point cycle counting technique as per ASTM standard. In a given spectrum, take any 3 points and find out the stress range with respect to absolute value and see whether delta S1 is greater than delta S2 or delta S2 is greater than delta S1. Based on that, one can identify whether a cycle can form or not. For the given example, when it's rotated by 90 degree, one can see that water, if it flows at 1, it will not gust out by 2, 3, because delta S1 is greater than delta S2. But if you see an example where rotate in the 90 degree, and you can see since 1 is below 0.3, if water starts flowing from there, it will get stopped by 2, 3. So delta S1 is less than delta S2, that is between 2 and 3. In another example, also it can be visualized water flows from the left side, and again it gets stopped by 2 and 3. So obviously it will form the cycle. Now, as per methodology concerned, for general in nature, the procedure is as follows. The total life method estimates the total fatigue life, including crack initiation and crack propagation, uses nominal stress as the control parameter. Fatigue life is computed from Sn curve. Fatigue life estimates are associated with probability of failure due to the large amount of scatter in the Sn curve. That's why finally one has to use the scatter factor. Variable amplitude loading is reduced to a list of cycle with a given range and mean or maximum stress or stress ratio using Rainflow cycle counting technique. Mean stress effects are considered by using either Goodman or Gerber algorithms. So this can be seen the procedure if you have a joint for which one has to calculate the fatigue life subjected to the variable amplitude loading. Obviously, one has to use the Rainflow cycle counting technique to find out the stress ratio and which peak and trough forms a cycle. And since a joint, then assuming that it has got stress concentration factor, one has to use Sn curve of that material of same stress concentration factor and also different stress ratio. So based on these two information, the damage can be calculated based on the minus rule, and the actual life can be estimated by dividing with the scatter factor. So this scatter factor is used to account the variability due to the material properties, manufacturing process, insertion loading, and accuracy in calculation model. Summary of method is shows when there is a constant amplitude fully reverse cycle, then it's just straightforward. I can use the appropriate Sn curve. Then when it comes to the block loading with stress ratios -1, obviously you have to use minus rule summation and compute the life. Then once you find the ratio, then use Sn curve to find the total life. Then when there's a mean stress, there is offset. Obviously, you have to use the Goodman's equation to make it equivalent amplitude with R is equal to -1. Then use the step 2, then step 1. When it involves irregular sequence series, obviously one has to use the Rainflow cycle counting technique to make it with the different stress ratio, then use the Goodman's equation, go to the step 2, then step 1. Thank you for patience hearing.